Good morning, good afternoon, and good evening to all those who are watching. My name is Ethan Bryant McQuhae. Good morning, good afternoon, and good evening. My name is Ethan McQuhae, and today I'll be giving a presentation on rehabilitating Utah Lakes ecology and relationships. I first off just want to thank a few people that made this research project and presentation possible. The Utah DNR, the Life Sciences Department at Brigham Young University, the Utah's Watershed Restoration Initiative, National Science Foundation, the Provo River Watershed Council, and the Utah Lake Research Collaborative. At the end of this presentation, if you have any questions or you do want to get involved with any more of our research, please just shoot me an email. My email is right there in the middle, ethan.mcq01@gmail.com. I'd be happy to chat with you, answer any other questions, and also let you know how you can get involved with this research. And so the research paper that we published earlier this year was how citizen science revealed unexpected solute patterns in semi-arid river networks, specifically in the Utah Lake watershed. And this was a very interesting project to be able to be involved with and also to be able to present today, because not only does it cover new findings for the Utah Lake watershed, but it also proposes new ideas and opportunities for citizens to be able to get involved with research projects. And we'll go over how that process went and how we and what we figured out and how we fared with that. And so first off, I just want to talk about how human modification in Utah Lake watershed has been such a problem that has gone unspoken. There seems to have been a disconnect up until this day between the citizens of the Utah Lake watershed and the watershed itself and its rehabilitation efforts. People generally, whenever you think of the Utah Lake, you think of icky and gross, and most people haven't even paid the Utah Lake a visit to see for themselves if that's the case. We have seen a high level of eutrophication in Utah Lake, which has caused massive damages to the entire watershed and also to endemic species and other things and other animals and flora that live in and around the lake. And so this disconnect has caused a plethora of problems in the Utah Lake. And not only that, it has led to also a lack of research on the lake, just because some people may think it's a lost cause, or they are too focused in other areas. And so there are also the people who are asking, why is the Utah Lake experiencing this eutrophication? And some researchers are saying that no, it's not human caused, it's just the environment that's changing, and it's something that's happening. We don't know what it is. But this research project shows that truly it is human caused, it's anthropogenic. And we'll go over how we figure that out and its effects on the entire watershed. And this modification of water and nutrient flows has led to the widespread degradation of the aquatic ecosystems in the entire watershed. And so our goal in this project was to understand the sources and sinks of nutrients and other pollutants in the Utah Lake watershed, to reconnect the residents with the rivers, lakes, and groundwater of the watershed, and to engage citizens in research to create public support and protection for restoration projects. And so we have also seen in Utah Lake that there are people that this is just an example of this disconnect. On the left side, people have become so disconnected and against Utah Lake, even though it is such an important water body in the Utah area in Western United States, that people are even considering filling it in. But with the Utah Lake Restoration Project proposal, we're now taking steps, as well as the Provo River Delta Restoration Project, we're now taking steps to be able to protect this important environment for its citizens. And so we'll go over first talking about why the watershed in and of itself is vulnerable to begin with. First off, it is a very, very large watershed. It's approximately 3,000 square miles that reaches up into the Wasatch, over into Uintas and elsewhere. And so Because of this, how large it is, it's a semi-arid climate, and it also needs a lot of water to be able to be there in the first place. It's in the semi-arid climate creates a different climate than we see in a lot of other watersheds across the United States, whether they be temperate or even other semi-arid climate watersheds. And so that changes a little bit what we predicted and what we ended up seeing. And also, this area is experiencing some of the fastest growth in the United States. There are over 600,000 residents in the watershed today, and they estimate by 2050 that there will be 1.3 million people living in the Utah Lake watershed. And so that will continue to exacerbate what we've been seeing in the watershed already. And lastly, population and policymakers don't necessarily understand Utah Lake. Like I was saying earlier, there is this disconnect between the watershed itself and its residents. People don't know how to take care of it. They think that it's too far gone and that it's always been this way. They don't necessarily understand why it's like that. For example, Deer Creek Reservoir is literally 4 miles, and much more people visit Deer Creek Reservoir compared to Utah Lake, which is massive in comparison. And so with the Utah Lake Research Collaborative, we created this citizen science project. We wanted to get the community involved and get them actually connected with the Utah Lake so that they could be able to see how they can be able to change the lake and be able to protect it themselves. And so it was student conceived and designed, this project. And our goals were to understand the sources and sinks of nutrients and other pollutants. And like I said earlier, reconnect the residents of the Utah Lake watershed with the rivers, lakes, and groundwater. And the design of this project was that we partnered with other organizations that have already been working on projects in the watershed, such as the PRWC and the Utah Water Watch. We got an online community, online and community groups start following us, and we started recruiting from these groups so that we could be able to have them get involved. We had clear and simple protocols and training. This training was represented in a few videos and a few steps to the volunteers, and it made it streamlined and easy for them to understand and not to taint data in any other way. It was festive sampling event. It was festive in our sampling events. We had giveaways. We had other ways to incentivize people to come and be involved. And it was in all seasons. We had it in the spring, summer, and fall. So there's 3 opportunities for people to come out and help. And lastly, we had analysis of a wide variety of solute and particulate parameters, including carbon, major nutrients, and also turbidity. And so the community outcomes, I believe, are some of the most important things that this research project showed. We had over 6,500 contacts at more than 10 community events. We had 350 participants and 6 citizen samplings. Over 200 sites were sampled, and participants had an overwhelming positive experiences across the board. We had children to adults to elderly helping with sampling across all of these sites. We also had other college-age students who may not have been necessarily in an environmental science or research position, but wanted to be involved with the watershed as well. And so these were our sampling sites. You can see they were all up different canyons. We have the Provo Canyon, Spanish Fork Canyon, Diamond Fork, Hobble Creek, and then other sites all across the watershed in and around the watershed. And so later on, we'll talk about this funnel shape that we noticed in the solute patterns. And so if we wanted to look up here, right where my cursor is, we'll define, I'll use the Provo Canyon as my example, but these are upper sampling areas down to this triangle right here, the WWTP. This is what we would consider our upper, we will go all the way down to the mouth of the canyon is our upper areas, upper and middle areas, upper down to the triangle, and then middle will be down to the mouth of the canyon, and then the lower areas will be from the mouth of the canyon until it goes into the lake. And that will be important for later, and we'll go over why. But you can see that we had a wide variety of sampling sites all across the watershed. And the reason why we picked all these sites is so that we could be able to not only get an understanding of how the water was dissolving solutes not only up in the mountains where snowmelt begins, but also how it changes throughout, experiencing different sinks and groundwater across the canyon, and also going into these human and urban environments. So we really wanted to get the citizens involved so they could recognize the beauty of Utah Lake, and then also be able to be connected and start on restoration projects, because they'll see how they have been affecting the Utah Lake watershed. And so going back to this page, we'll talk a little bit about our findings. Our study confirmed that there was a unique hydrochemistry of semi-arid and mixed natural urban regions in the Utah Lake watershed. And so first off, the urban point sources are disrupting spatial variability, and the solute concentrations changed all across the watershed and didn't necessarily follow what we expected them to show. And then lastly, that citizen science is actually very useful and very helpful. It's a means to an end in research and in the science fields. So first off, I'll start with the difference in solute patterns. And so we expected that the solute patterns would be a lot higher, more dense, higher up in the upper elevations, but the opposite actually showed. For example, you can see it most here in this picture, in this analysis, that we expected most of the red hotspots. These are higher concentrations in the red, and the yellow are lower concentrations. We expected the higher up where the point sources were, that we would see higher solute concentrations, but actually they were closer to the lake where land was developed, except for in dissolved organic carbon. You can see it's a little bit more kind of what we expected up in the upper, but down in the lower, definitely there was the same thing that we saw earlier. Excuse me. So less than 20% of the landscape was contributing to a majority of the nitrogen and phosphorus in the entire environment. And so we can see that here, total nitrogen and the phosphorus, less than 20% of the landscape. It's most present here in the nitrogen graph. We can see that, that all these areas where it has been developed are high concentrations of nitrogen as well as phosphorus. We can see the lower we get in the watershed where that development has begun, that there's a higher concentration of almost everything. And impervious cover is correlated with higher concentrations of phosphorus, nitrogen, chloride, and sulfate, and that the valley sites, Heber and Utah valleys, were higher in all solutes except carbon, especially in springtime. And that rivers, wetlands, and lakes are generally acting as sinks for carbon and phosphorus, but are sources of nitrogen. And so what I mean by that is that throughout the entire year, throughout each sampling period, rivers, wetlands, and lakes were acting as carbon and phosphorus sinks, but they were actually being creators of nitrogen. They were putting out nitrogen into the river networks, which was different than what we expected as well in our findings. And so here's a snapshot of those graphs that are a little bit bigger, where you can see the phosphates, the dissolved organic carbon, and other solutes. And so here we talk about the spatial variability and how that was not what we expected to see. And so what we expected to see was this funnel shape that we usually see in other semi-arid and temperate climates, where at the beginning, there's a lot of point sources of these solutes, and then as it gets closer to the end, where it distributes into the lake, that it funnels off where these solutes are lower. But we actually saw more of an hourglass shape in our findings up in those upper regions of the watershed, we were seeing that high persistence across all of our samples. And then as we were entering those middle stages, like from that triangle down to the mouth of the canyon, it did funnel off. But as soon as we got into the developed areas from the mouth of the canyon until Utah Lake, we saw the opening of that funnel where there were, like I said, over less than 20% of the watershed was contributing to the majority of the solutes in the total watershed. And so we did not whatsoever expect to find that, but that has shown us that it is anthropogenic effects that are putting back in a majority of these solutes that were being sunk into the rivers and lakes and other watershed and other parts of the watershed. And then once it gets into these more developed areas right before Utah Lake, we're adding in an enormous amount of nutrients and other elements that are being dissolved and causing this eutrophication. And so the uptake in this kind of gives you a snapshot of the uptake in production in the river network. And so in the spring, it shows the production of these solutes throughout each season. And this is kind of talking about dissolved organic carbon, that other picture we were showing. And so going over how they were acting, the rivers, streams, and lakes were causing as sinks for carbon, and carbon you can see here, and then phosphorus as well. They're having sinks, whereas as nitrogen, they were actually adding back in these solutes into the network in all seasons. And so lastly, I come to some recommendations based off of our research. We want to foster community connection and understanding through education and recreation. One of the key ways that we can be able to get more residents of the Utah Lake watershed involved is through these citizen science projects. People were able to understand why the Utah Lake was important and also understand what animals and plants live in the Utah Lake that depend on its healthiness, and also how they can be able to benefit from Utah Lake as well. And so by involving residents in education and also in research of Utah Lake, it builds a connection with the watershed. We also wanted to work with valley bottom communities who are affecting this watershed the most. We wanted to decrease water use, including agricultural water use, which is contributing a majority of these solutes, to allow more in-stream flow and also allow these nutrients to sink and elements to sink into those areas, into the rivers and streams. We want to also improve nutrient management. We want to have stormwater infrastructure and also make sure that we are not contributing to the problem of eutrophication in the Utah Lake and destroying its environment. We want to protect the lake from irresponsible and dangerous proposals, such as filling back in Utah Lake for development projects, among other things. With this connection that we can foster, we can be able to help people understand the importance of science and also help people build their dependency on Utah Lake and other watersheds across Utah. And lastly, just want to thank all these people who have made this project possible. Without them, we wouldn't be able to have completed this project, nor would it have gotten to be as big as it was. I just want to leave y'all with these recommendations, and also a commitment that we will continue to work on these projects and build these connections with the community. Our watersheds are of utmost importance these days, and we have seen the consequences, and we are beginning to really see the consequences of our hand on these watersheds. We have seen eutrophication, we've seen drying up of watersheds, we've seen the pollution that comes from agricultural use, and also mismanagement of these watersheds and also the consequences of disconnect from our watersheds. And so we want to continue to foster these communal gatherings to understand these watersheds and also continue to protect these watersheds. I know that as we continue to work together as a community to protect these watersheds and also as a scientific community to research and protect these watersheds, that we can truly see a difference in the standard and quality of life of our citizens in the greater Utah area, and also be able to see a renewal in the environment and ecosystem that surrounds these very important watersheds. And so I thank you for watching, and I hope you all have a good rest of your day and enjoy the conference. And again, if you need to reach out to me, my email is ethan.mcq01@gmail.com. Just shoot me an email with any other questions you have, and I look forward to hearing from you. You have a good day.